So in this video, we're going to talk about a second formula we can use to find a slope of a tangent equation for a specific point on a curve. So if you take a look at our formula here, you can see that we actually end up having an h value now. We can let h be defined as x minus a. And then, as you can see for our first function here, we just add our a value plus the h value minus the function with the a value plugged in. So let's take a look at a quick example of that. Let's say we have a function. Say we have a function of radical x and an a value of 4. One thing that we do need to define, since we just have an a value, since we're going to try and find the equation of the tangent line, we're going to need both an x and y coordinate. So you can assume that the a value is our x coordinate. So what we're just going to do is rewrite this as y equals square root of x, and then we can just plug this a value in here, and then that gives us a value of 2 for y. So we end up with a point of 4 for our x and 2 for our y. Now that we have this, we can go ahead and start plugging everything into this formula over here. So we'll write our limit here. And then we have our function 4 plus h minus function 4 all over h. So like the last formula, what this is telling us is that this is what's going to go inside our function here. So we have to plug both this 4 plus h into our original function and then subtract it when we plug this 4 value into our original function. So we end up getting, when we do that, we'll get a radical 4 plus h, and then once we plug this 4 value in, obviously we just get a 2, so minus 2 all over h. Now we've seen this before when we solved for these limits algebraically, so we're just going to go ahead and get the conjugate of this. So we're going to multiply both the numerator, so 4 plus h. So we're multiply the numerator and the denominator by our conjugate. So we just change the sign here from a negative to a positive. So 4 plus h plus 2. So when we multiply these, our numerator out, our radical ends up canceling out, and then when we distribute the 2's, we end up with a numerator that's going to be 4 plus h minus 4. And like usual, we just leave our denominator alone, so we'll have h times our radical 4 plus h plus 2. These 4's cancel out, and then from here we can even cancel these h's out. So we end up getting a 1 over radical 4 plus h plus 2 again. So as you can take a look here, you can see that we can plug in this limit now, and we'll end up getting a real value. So let's just go ahead and do that. So that ends up giving, let's see, 1 over 4 plus 0 plus 2. That gives us a 1 over 4. So this is our slope value, and we can use our point slope intercept formula again. So if you forgot that, we'll just write over here. So we have y minus y1 is equal to our slope times x minus x1. So that's why we needed that x and y point in the beginning, if they just gave you an a value, so we can plug it in here and find our final equation. So in this case, we have y minus 2 is equal to 1 over 4 times x minus 4. That gives us a final equation for our tangent line of y equals 1 over 4 x plus 1. That's our slope. So pretty straightforward. Just remember that you just have to plug these back into your function. Since h is a variable now, you're going to have this, whatever your a plus this h value is inside your original function. So let's take a look at an instantaneous velocity problem, which I think is kind of interesting. So let's say distance is equal to our function in regards to time. You can make this assumption that our instantaneous velocity is this equation, because we're essentially finding the derivative of that point. So whatever value we get here would be our instantaneous velocity. So let's assume that we have an initial velocity of 40 feet per second. So I'll write this here. V naught. So we want to find. So let's assume we're going to throw a ball in the air at this initial velocity of 40 feet per second. So we want to find our height in feet after a certain amount of time. So our height in feet. Or excuse me, this is our function for distance. So our height in feet after a certain amount of time. T seconds. So that's could be y is equal to 40 t minus 16 t squared. So this function gives us our height. So like what we assume here, if we have our distance, which is given to a function, we can use this formula to find our instantaneous velocity. So when we want to find our velocity, find v after 2 seconds. So let's kind of rewrite everything. So we have y is equal to our function of time, and that's equal to 40 t minus 16 t squared. And we want to find v, and our a value is going to be 2. So same thing. We'll just use this formula, and so we get v2 is equal to the limit, which is h to 0. And then since our a value is 2, we'll use 2 plus h. So, and plug it into our original function here. So we have 40 times 2 plus h. And then we also have to account for this minus 16 here, because both the 2 plus h's need to be plugged into both our t variables. So we have minus 16 2 plus h squared. So this takes this first part right here. We're just plugging in that a plus h into our original function. Now we need to plug in 2 into our function. So that'd be 40 times 2 minus 16 times 2 squared. And all of this is going to be over h. Now we're going to go ahead and just distribute. We'll distribute this out, and then we can expand this and then distribute it with the negative 16. So we'll do that one step at a time here. So we have our limit here. Then we'll have 40 times 2 is 80 plus 40h. And then expanding this out, we'll go ahead and write our 16, and then our expansion comes out to be 4 plus 4h plus h squared. And then calculating this out, we have a negative 80 and a positive 64. So our 80s cancel, and this is all over h. And then now we can distribute this and kind of see where we're at. So we have a 40 h, and then negative 16 times 4 is negative 64. And then once again another negative 64h minus 16h squared plus this remaining 64. So we cancel these 64s out. And then you can see this is starting to clean up a little bit. And then we subtract this negative 64 from 40. So that gives us a negative 24h minus 16h squared over h. And then we can factor an h out. H is canceled here. And then now, since we don't have anything in the denominator anymore, we know we can plug our limit in. So we have negative 24 minus 16 times 0. And that gives us a final answer of negative 24 feet per second. So that's pretty much it for these. It's a little tedious to do it this way. As we progress on, we'll find easier ways to just find the derivative of the formula and be able to solve that way. But if you're asked, instantaneous velocity problem using this formula, just know that just try to write everything out. Just remember that you just got to plug these this a plus h value and this a value here back into your original function. Then you can kind of just use our traditional algebra rules until we finally get to a final answer here.